Welcome to online classes. Today we discuss a new chapter, that is probability. In previous session we completed the chapter determinant and matrix. So today we discuss about probability. As you know, probability you learned in first year that probability of A, P of A, okay, probability of is denoted by P of A. And probability of the formula of P of A. The formula of P of A, that is number of events, that is number of A that divided by number of sample space. Okay. So as you know, in first year, probability of A is equal to number of A by number of S. And you also know that probability of A is lies between 0 to 1. Okay. So today we discuss in second year that what is conditional probability. So first we started in your course that conditional probability. So first we have to know what is conditional probability. Okay. So, what is conditional probability? That means we have to compare two events, that is A and B. So, when A and B are events, in a sample space, as you know, we denoted sample space in the letter S. When A and B are events in a sample space S, the conditional probability T of A subject to B, which is denoted by P of A by B. When A and B are events in a sample space S, then the conditional probability of A subject to B, which is denoted by P of A by B, and it is defined as that probability of A by B, that is equal to probability of intersection of two events. That means here you can see A and B are two events, so intersection of two sets by probability of B. So this is the formula of conditional probability. You can say in this case conditional probability of A subject to B, because here we can write P of A by B. So the formula of P of A by B, that equal to probability of A intersection B by P of B. Here we can see B is the denominator, so here we can write the same events in denominator. So probability of A by B, that equal to probability of A intersection B by probability of B. But here is the condition that probability of B is not equal to 0. If value is 0, then we cannot define of conditional probability of A subject to B. Okay. So here is the condition that denominator cannot be equal to 0. Okay. Similarly, you can write probability of B by A. So what we write? The formula of probability of B by A. The probability of B by A, that is equal to probability of, we can write here because it is interchange of A and B, so we can write B intersection A because we know A intersection B is equal to B intersection A. So we can write here A intersection B or B intersection A by, as you see here, A is the denominator or divided. So we can write here probability of A. So similarly you can write another formula that probability of B by A that equal to probability of A intersection B by probability of A, and its condition is probability of A is not equal to 0 in this case. Okay, so this is the formula that A subject to B, probability of A subject to B, and probability of B subject to A. Now we discuss or we can apply this formula in a problem. So how to apply this formula? Before we started a problem, first we have to know some formula that you will learn in first year. Okay, so first we have discussed some formula that you learn in class 11. So here is the formula. That you learn in class 11, that first formula number 1, that probability of complement of A, will know that you can say in this form, that is probability of complement of A. Okay, we can write in this form to the power C, or you can write this. Okay, so probability of complement of A that equal to 1 minus probability of A. So this is the first formula. Then next proceed to second formula, that is probability of A union B. According to set theory, as you know, A union B, continuity of A union B is equal to continuity of A plus continuity of B minus continuity of A intersection B. Similarly, you can apply this formula. So we can write here probability of A union B is equal to P of A plus P of B minus P of A intersection B. If you take your union, then you can write here intersection form. Okay, so if you write in intersection in this case, that means we can take intersection into left hand side, then union can be taken into right hand side. So you can write here probability of A plus probability of B minus probability of A union B. Similarly, you can say if you take your union, then you can write here intersection. If you take intersection, then you can write union. Okay, so this is a similar formula that you can write. Next, formula number 4, that is probability of A intersection B. Probability of A intersection B that equal to P of A plus P of B. You can write P of A plus P of B. But it is a condition that if A and B are mutually exclusive events, or we can write another word, that is disjoint set. If A and B are mutually exclusive events, or you can say in other words disjoint set, that means this value A intersection, disjoint means A and B are disjoint if both in set, no common element in both set. Okay, so this is called disjoint set. So if disjoint set, that means their intersection must be 5. So probability of A intersection B is 0. So this term will be vanishes, or we can write 0. So we can write probability of probability of A union B, not A intersection B. Okay, probability of A union B is equal to P of A plus P of B. This term is mentions because if the condition is mutually exclusive means, so probability of A union B is equal to P of A plus P of B. Next, proceed to formula number 5, and that is probability of A complement union complement of B, that you can write 1 minus probability of A intersection B. And another formula, probability of complement of A intersection complement of B, that is equal to, we can write 1 minus probability of A union B, because these two formula are known as De Morgan's law. Okay, according to De Morgan's law, we can write here complement of A union complement of B, that is equal to 1 minus probability of A intersection B, because here if you take intersection, then you can write here intersection. Similar to the formula number 6, that is probability of complement of A intersection B complement of B, that is equal to 1 minus probability of A union B. That means if you take here intersection, then you can write here union. Okay. Next, formula number 7, probability of A intersection complement of B. In this case, here the complement of B only, not A. So probability of A intersection complement of B, the formula is probability of A minus probability of A intersection B. And formula number 8, that is probability of complement of A intersection B, that is equal to probability of B minus probability of A intersection B. Okay. Next, proceed to formula number 9, that is probability of A union complement of B. These two formulas are similar, and formula number 5 and 6 are similar to each other, and you can see formula number 2 and 3 are similar to each other. So next, proceed to formula number 9, that is probability of A union complement of B. You can use this formula number 2, that is probability of A union B. So here you can see probability of A union B, the complement of B. So we can use this formula 2. So according to this formula number 2, we can write here probability of A plus probability of complement of B minus probability of A intersection complement of B. Okay. So if you simplify these values, if we simplify this value, that is equal to P of A plus, what is the formula complement of B? As you know, in formula number 1, that is probability of complement of A, that equal to 1 minus P of A. So here we can write 1 minus P of B minus, so what is the formula of probability of A intersection complement of B? So here we can write probability of A intersection complement of B, that is, we can use this formula, that is formula number 7, that is P of A minus P of A intersection B. So we can write P of A plus 1 minus P of B minus P of A plus P of A intersection B. So we cancel both P of A. So we finally we can write here probability 1 minus probability of B plus probability of A intersection B. So this is the formula that we have probability of A union complement of B, that is equal to, as you know, formula number 9, probability of A union complement of B, that is equal to 1 we can write here, or finally you can write probability of A union complement of B, that is equal to 1 minus P of B plus probability of A intersection B. So finally we have learned that probability of A union complement of B, that is equal to 1 minus P of B plus P of A intersection B. Now proceed to formula number 10, and that is the last formula, and that is probability of complement of A union B. Similarly we write, if we take complement of B, then we can write here probability of B. So if here in this case probability complement of A, so we can write 1 minus P of A plus probability of A intersection B. So these are the formula that we have learned in class 11. So in this, according to this formula, you can use this in conditional probability. So let's start a problem that you can use this formula in this problem. Okay. So you can check a formula. Now we can take a formula. So we can take an example, that is, if A and B are two events, if A and B are two events such that P of A is equal to 0.3, P of B is equal to 0.4, and P of A union B, probability of A union B, that is equal to 0.6. Then find the probability of A by B. In second bit, probability of B by A. In third case, probability of A by complement of B, and fourth is probability of B by complement of A. So how to solve these values? Okay, so here is the solution. First we have to write that given in this problem, that is given, we can write P of A is equal to 0.3, okay, P of B is equal to 0.4, and lastly probability of A union B, that is equal to 0.6. So these are the givens of this problem. Now we have to solve question number first, that is probability of, we can write conditional probability of A subject to B, or simply you can say probability of A by B. So probability of A by B, the formula of probability of A by B, as you know in first, that is probability of A intersection B by probability of B. Okay, so have you the value of probability of A intersection B in the given? No. So now we can use this formula, probability of A union B. As you know, the formula of A intersection B, that is P of A plus P of B minus P of A union B. This is the formula that you learn by probability of P. So all these values are given in this question, so we can put this value, that is P of A, that is 0.3 plus probability of B, that is 0.4 minus probability of A will be, that is 0.6 by the value of P of B, that is 0.4. So here if we calculate these values, 0.3 plus 0.4, 0.7 minus 0.6, that is 0.1 by 0.4, or you can write here 1 by 4. So this is the solution of first bit. Okay, next proceed to question number 2, that is probability of B by A. Okay, so probability of B by A, that means we can use this formula, that is probability of A intersection B by P of A. So as you know the value of probability of A intersection B, that is 0.1 in first bit. So you can put this value because we have already calculated this value. So we can put the value of probability of A intersection B, and that is 0.1. Okay, by the value of P of A, that is 0.3. So we can write here the final answer, that is 1 by 3. So the value of probability of B by A, that is 1 by 3. Now question number 3, that is probability of A by complement of B. Probability of A by complement of B. So similarly, when we use this conditional probability, that is probability of A intersection complement of B by probability of complement of B. As you know, in conditional probability, that intersection of both event by the event which is divided or which is a denominator of this expression. So we can write probability of A intersection complement of B, then divided by probability of complement of B. So here we can use this formula, that probability of A intersection complement of B, that is probability of A minus probability of A intersection B by probability of complement B, that is 1 minus P of B. So the value of P of A, that is 0.3 minus, so what is the value of probability of A of B? In bit 1 we have already discussed the value of probability of A intersection B, that is 0.1. So we can write here 0.1. If you have not value of probability of intersection B, then you can calculate this value and then you can put this value. Okay, by 1 minus probability of B, that is probability of B, value of probability of B is 0.4. So we can write 0.2 by 0.6, or we can write 2 by 6, or we can write finally 1 by 3. So this is the solution of question number 3. Next, proceed to the fourth bit, and the fourth bit is probability of B by complement of A. Probability of B by complement of A. So similarly, you can write probability of complement of A intersection B by probability of complement of A. So here you can put, or you can apply this formula, that is probability of complement of A intersection B, that is probability of B minus probability of A intersection B, whole divided by 1 minus P of A. So here you can put this value, that probability of B, the value of probability of B is 0.4 minus probability of A intersection B. As you know, in bit 1, that is 0.1 by 1 minus P of A, that is 0.3. That means 0.3 by 0.7. that equal to 3 by 7. So these are the solutions of this given example. Okay. Now you can solve this another example. And that is your homework, that you can derive this problem. So this is your homework that you can done in your home. That is, if A and B are events, if A and B are events such that P of A is equal to 0.6, P of B is equal to 0.4, and probability of A intersection B is equal to 0.2. Okay, P of A, P of B, and P of A intersection B 0.2. Then find probability of A by B, probability of B by A, and third one is probability of A by complement of B, and fourth is probability of B by complement of A. So this is your homework that you can done. Okay. So this is for your homework that you can done. So I think you can understand this chapter clearly. Have a nice day.